Hey everybody. Today I just wanted to share something I've been working on for a little bit. But essentially, what this is a LabVIEW wrapper for Bouncy Castle. So if you don't know what Bouncy Castle is, I actually have the website pulled up here. But Castle is just an open source cryptographic API. So it's kind of built through community involvement. It is FIPS certified. It actually has been for a long time. And it just has all sorts of stuff. So, anything from, just basic, hey, hash operations, encoding, encryption, key generation, but also beyond that, right? You can actually do full blown, TLS through this. You can do, a whole bunch of different communication protocols, all sorts of stuff. It's actually massive. So I've been going through and in LabVIEW starting to map so they do have APIs for Java and C Sharp. So I see C Sharp and I think, oh, .NET. So yeah, and it actually got the DLLs downloaded and it imports into LabVIEW just fine. So yeah, basically just going through and trying to kind of map, the C Sharp calls to the equivalent LabVIEW, functions and, getting all that working. This is what it's built on. You can see it's been around a very long time, 24 years, and it's been FIPS certified for 6.2 million downloads per month. So this is really widely used, as in terms of like a good crypto standard. This is a fantastic way to do it. Just a little bit of about what this is. And if you want to look through their website, they have a ton more documentation and stuff and things about what you can do and other people that have used this. So it's just bouncycastle.org if you want to look through it. So kind of what I have so far, I've built a library and I've been slowly mapping stuff. This Bouncy Castle library is just absolutely massive. So even if I was working on this full time, it would still take me a very long time to map everything. But I've been doing a little bit here and there. So I did include our libraries. So this is our bouncycastle.crypto DLL and bouncycastle.cryptography. So those are kind of the dependencies. We're wrapping all of those functions. And then there's a whole bunch of different stuff, right? So, key generation, right? And beyond just saying, hey, generate a key of X length, it actually is able to generate all sorts of different either keys or key pairs. And one thing I wanted to highlight that is really cool about Bouncy Castle, I think, is that it supports, it has algorithms that are part of the kind of post-quantum cryptography movement, right? So if you don't know what that is, I don't want to really dive into it too much, but essentially the idea is with current cryptographic methods, the idea is that, trying to basically get to calculate the private key from a public key using something that might be used in like TLS, could take someone, a computer hundreds, if not thousands of years to try to get to that, right? If you actually get access to the private key, then boom, you're in. But trying to calculate the private key from the public key just isn't really feasible right now. So if you're using good standards, your data is very secure. The idea though is that with quantum computing, as it slowly becomes more and more accessible, right? Right now it's, really only in certain research labs, but as that technology advances, the idea is, someone might not be able to actually, steal your data right now. Even if they were listening in and capturing packets and stuff, they get this encrypted, jarbled mess. And to try to decrypt it is just not even really feasible. But the idea is they could just harvest that data and store it for the time being. And then once quantum computing becomes available, some hacker is able to access that technology, well, now they can use quantum computing to crack that stuff in maybe a matter of hours, right? And then they can have access to all sorts of data. So there are new kind of algorithms that have come out that are called, are kind of labeled post-quantum cryptography, right? So our current standard, what we're using, it works great for what we have right now. But for quantum computing, we kind of have to step that up even further. So Bouncy Castle actually has a whole bunch of post-quantum cryptographic functions specific to generating keys and stuff, right? So we want to make sure that we're, not just protecting against, today's problems, but also the future, right? So yeah, just kind of one thing that I thought was cool about Bouncy Castle was that they had great support for that. And they actually have lots of documentation on which algorithms are part of their kind of post-quantum movement, which is cool. So yeah, there's all these functions for generating keys and whatnot. And so you can see, it's basically just a whole bunch of .NET wrappers, right? Where, we're, constructing some stuff, calling some methods, getting our data. So we can do stuff like that to generate our keys, key pairs, et cetera, et cetera. And this will output, my class that is my keys, and then I can use other methods to export those or to pass them into different other functions and whatnot. So yeah, stuff like that. Stuff for working with IP addresses, so checking if IP addresses are valid and if they use IPv4, v6, support for base 64 encoding and decoding. They have a whole slew of random number generation capabilities, so I've mapped some of those, things for hashing, miscellaneous, and, encryption. It has support for certificates, generating those. I have some stuff mapped, but there's a ton more that this can do, right? And you can see it in terms of encryption, I have very little mapped so far. My plan as I move along is to eventually try to map the entire library, but I'll be doing that as I have time, and so it may take me a very long time. But where I currently am, all of this is actually pushed to my GitLab. So if you go down to the description of the video, you can actually find the link to that if you want to start using this as is. And if anyone is willing to, help work on this, I think it'd be a fantastic tool for the community to wrap this entire Bouncy Castle library. I think it would check so many boxes for so many people in the aerospace and defense sector. I'm going to keep working on it, but if anyone wants to collaborate with me, feel free to make a pull request or reach out to me. We can collaborate on, mapping functions and whatnot even further. For right now, this is kind of what I have so far, and I'm going to keep going. So if you want to play with this and start using it, it is in my GitLab, like I said. Documentation here, they actually are, if you go to the C# documentation, they have some pretty good documentation, but a lot of it is still in active development. So, for certain things, there's good documentation, and for some things, trying to find the exact link. So as you can see, there's this a user guide and C# examples. And it does say that it's a work in progress, so it's not finished. So, but for some things it is. So, if you need to, you can open it up and kind of find out. Oh, I don't want to make an account right now, but so it's there in my GitLab if you want to work with it. This library is available there. And I'm going to keep building on it. And, every now and then as I've added some new stuff, I'll, push that. So, keep checking in if there's a feature of Bouncy Castle that you want that's not available. The plan is for it to be there eventually. And if you want to work on this with me, let me know. Let's work on this together and make it, I think, a really, really cool tool for the LabVIEW community for anything security. I think it'd be fantastic. So, thank you guys for watching.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.